Good morning, children. So today we are going to start chapter number 8, quadrilateral. So first you need to know one of the most important quadrilateral, that is the parallelogram. You have got it in class 7, 8. So in 8 you have got. So now let us know what is the parallelogram. A quadrilateral in which both the pairs of opposite sides are parallel. So to define a parallelogram, you are to make the two opposite pair of sides parallel. That means AB is parallel to DC, then AB is parallel to DC. If both the pairs of opposite sides are parallel, then this will be called parallelogram. So if they will ask you that how you define a parallelogram, then the simple answer is if in a quadrilateral both the pairs of opposite sides are parallel, then that will be called a parallelogram. Now here you need to know the properties of the parallelogram. So now number 1 is diagonals of a parallelogram are bisect each other. Parallelogram bisect each other. So here it means that, so you know the word bisect. So that means here both the diagonals AC and BD will bisect each other. That means dividing the segments into equal parts, which means AO equals to CO and BO equals to DO. This means bisect. So the two diagonals will bisect each other at the point O. That means O is the midpoint of AC as well as of BD, which means AO equals to CO and BO equals to DO. So this is the first property. Second one, opposite sides are equal and parallel. So here in the case of parallelogram, opposite sides must be equal. That means say AB equals to DC and then BC equals to AD. So the opposite sides will be equal as well as the opposite sides will be parallel. So that means AB is parallel to DC, BC is parallel to AD. Also opposite sides are equal, which means AB equals to DC and BC equals to AD. So this is the second one. Third point is opposite angles are equal. So the opposite angles. Now here the opposite of angle B is angle D. So they are called adjacent. They are not opposite. So this will be the opposite of B. That is angle D. So B and D measurements will be same. That means equal. Supposing this one is 60 degree. This also will be 60 degree. And then angle C equals to angle A. So now these are the three important properties of the parallelogram. Now to define a parallelogram, just you are to know that if both the pairs of opposite sides are parallel, then this figure will be called a parallelogram. So here in this chapter, you are to give more stress on the properties of the parallelogram as well as its definition. So now we will be doing the first theorem. Let us take the first one. So first theorem. So it is proof that a diagonal of a parallelogram divides it into two congruent triangles. So the first theorem proves that a diagonal of a parallelogram divides it into two congruent triangles. So here the figure is given as a parallelogram. So you will draw a parallelogram. So say it is ABCD. Then here they have mentioned about a diagonal. So they have not said about the two diagonals. They have said a single diagonal. So prove that a diagonal, that is a single diagonal of the parallelogram, divides it. So divides the whole parallelogram into two congruent triangles. So you may join either AC to get the diagonal AC, or you may join B and D to get the diagonal BD. Let us join AC. So they have given a diagonal, so a single diagonal. You have joined AC to get the diagonal AC. Now they have said this diagonal AC should divide this parallelogram ABCD into two congruent triangles. That means you will make the triangle ABC congruent to triangle CDA. So you will make these two triangles congruent. Now, before we start the proof, so since a parallelogram opposite sides are equal as well as parallel, let us take the two sides, say like AB and DC. So in the triangle say ABC, in triangle ABC, and then the triangle CDA. So CDA. So in both the triangles you have got that the opposite sides are equal, because the figure they have given as a means parallelogram. Secondly, here AD equals to BC, so the opposite sides they are equal. And then in both the triangles you have got the common side AC. That is why the two triangles becomes congruent by side. Also there means, so the first one you have made the triangle congruence. So you have made triangle ABC congruence to triangle CDA by SSS, or else you can make these two triangles congruent by, since here AB is parallel to DC, BC is parallel to AD, because the figure is a means parallelogram. That is why if AB is parallel to DC, so here AB, this is DC, and then you join it. So now you see, you will get that since AB is parallel to DC, you will get these two angles equal, because they form a pair of alternate interior angles. Also you can say that angle B equals to angle D, because the opposite angles of a parallelogram are equal, because this is one of the properties of the means parallelogram. So your B and D is equal, and then you can take this common side, say like AC. So in this case the triangles are congruent by angle side, or else you may take that these two sides equal. Supposing you have not taken the common side, you have taken that this angle A equals to angle C, that is DCA equals to BAC, so alternate, because DC is parallel to AB. And then you took AB equals to DC, because opposite sides of a parallelogram are always equal. Then you have taken say the angle say B equals to D. In that case, the two triangles will be congruent by angle side angle. So this proof you can do it by many other ways. So here the most simple is SSS, or you may try angle side angle or AAS. So in so many ways you can prove its congruence. So here we will be proving it by side, which is the simple one. So here the figure is given as a parallelogram. So let ABCD be a parallelogram. So in short, the parallelogram we write in this way. So it is parallel, then here just you put GM. So it is, in short, this will be called parallelogram. So now let ABCD be a parallelogram in which AC, so AC is its diagonal, Now to prove triangle ABC, congruent to triangle. So ABC. So now it will be CDA, not ADC. So here angle A corresponds with C. Since you took A, you will take C. So CDA. So CDA. Now here the proof. So you will make the two triangles congruent. So in triangle ABC and triangle CDA, so in both the triangles you have got from these two triangles their corresponding parts. So AB equals to DC. So AB equals to CD. Then you got that BC equals to AB. So BC equals to DS. So BC equals to DS. So the same reason. Reason is opposite sides of a parallelogram are equal. So opposite sides of a parallelogram. So in short, we write this way: parallelogram are equal. So are equal. So these two are equal. So they are opposite sides. Now in both the triangles you have got the common side AC. So AC equals to AC. This is the common side. Common side. So you have got the three conditions. Therefore, triangle ABC congruent to triangle CDA. So triangle CDA by, so side. So you take this triangle ABC. So you took the side AB, you took the side BC, and you took the side AC. So the side. So the two triangles are congruent. So hence, so it is proved. So this theorem can also be proved in angle side angle or by AAS or by angle side. Let us take one more theorem. If each pair of opposite sides of a quadrilateral is equal, then prove that it is a parallelogram. So it is a parallelogram. So in short, parallelogram. Now, so here if each pair of opposite sides of a quadrilateral is equal, so now both the pairs of the quadrilateral are equal, then prove that it is a parallelogram. So now here we will draw the figure like a parallelogram, because you are to prove that the quadrilateral must be a parallelogram. So A, B, C, D. Now here they have given that it means each pair of opposite sides of the quadrilateral is equal. So now here they have given that each pair, so AB equals to DC and then AD equals to BC. Now you are to prove that the given figure should be a parallelogram. So for this we can join any one diagonal. Either you join A to C, you will get the diagonal AC, or you join B to D. So let us join A and C. This is the construction part. So you can join either BD or you can join AC. Now here we will make the triangles congruent. Here you will make the triangles congruent, and then by making the triangles congruent, we will take their corresponding parts. Let us take in this one, in the triangle ABC and CDA. So AB equals to DC. Why? Because this one is given, because they have given each pair of opposite sides equal. So here both the pairs, so they are the opposite side. This is the first pair, this is the second pair of sides. So they are now equal. Secondly, BC equals to AD. This is also given because the opposite pair of sides are equal. Then you got the common side AC. So that is why the two triangles are congruent by side, side, side. So as these two triangles are congruent, you will get their corresponding parts also equal. Let us take, say, this equals to this angle. That means angle BAC equals to angle DCA. They form a pair of alternate interior angles. So these two are the alternate interior angles. Also, you will get this angle, that is angle ACB equals to angle CAD. So these angles are equal. So they also form a pair of alternate angles. That is why, since this forms a pair of alternate angles, that is why BC is parallel to AD, and these two angles also form a pair of alternate angles. That is why AB is parallel to DC. When both the pairs of opposite sides are parallel, then this quadrilateral becomes a parallelogram, because as we have defined the parallelogram, that quadrilateral having both the pairs of opposite sides parallel. That means if both the pairs of opposite sides are parallel, that will be called a parallelogram. So by making these two triangles congruent, you have got that their corresponding angles are equal. So but they form two different pairs of alternate angles. That is why AB is parallel to DC and BC is parallel to AD. Both the pairs of opposite sides are parallel. That is why ABCD is a parallelogram. Now here they have given that the figure is a quadrilateral. So here let ABCD be a quadrilateral. Be a quadrilateral. So if each pair of opposite sides are equal, so they have given that the opposite pair of sides are equal. So such that so here AB equals to DC. This one is given. Each pair of sides are equal. So here then AD equals to BC. Now to prove quadrilateral, so in short QUAD dot. So this will be called quadrilateral. ABCD is a parallelogram. So in short, you will write in this way, parallelogram. So now proof. So here construction. So you have joined A and C. So AC is joined. So AC is joined. Now comes proof. So in triangle ABC and triangle CDA, in triangle ABC and triangle CDA, so CDA, so here AB equals to DC. So AB equals to DC. Why? Because they have given, this is the given part. So AB equals to DC and AD equals to BC, because each pair of opposite sides is equal. That is why this one is given. So here you will write given. Then the next one is BC equals to AD. So BC equals to AD. This is also given. So BC equals to AD. This is also given. Then you have got the common side AC. So AC equals to AC. This is common side. Common side. So you have got the three conditions. Therefore, triangle ABC congruence to triangle CDA by side, side, side. So in the triangle ABC, you took the side AB, you have taken the side BC, and you took the common side AC. So the triangles are congruent by side, side, side. So by SSS. Now as the triangles are congruent, as the two triangles are congruent, so you have got that here corresponding angles are also equal. So here angle A corresponds with angle C, angle C corresponds with angle A. So that means from this if I take, therefore, so from this congruence, so it follows that angle BAC equals to angle DCA. So angle DCA. Now you see BAC, so BAC, this angle equals to DCA, so DCA. So these two angles are equal. This is by simplicity. So then and then you have got angle C corresponds with angle A. That means BCA, angle BCA equals to angle, so it will be DAC. So it will be DAC. It is also by simplicity because you have got these two from the congruence of these two triangles. Now here BCA, so BCA, so this angle equals to angle DAC, so DAC, so this angle. So but they form, this and these two angles, they form a pair of alternate angles, and these two angles form the second pair of alternate angles. So but they form a pair of alternate interior angles. So alternate interior angles. So therefore you will get that since these two angles are equal, they are now alternate because AB is parallel to DC. So AB is parallel to DC, and since these two angles are equal, so here C and A. So sorry, this and these two angles are equal. That is why they form a pair of alternate. That is why AD is parallel to BC and AD is parallel to BC. Now here you got that the two pairs of opposite sides are parallel. That means if both the pairs of opposite sides in the quadrilateral are parallel, then the figure will be called a parallelogram. So therefore ABCD is a parallelogram. So it is proved. So to get a parallelogram, now here one more thing you have learned from this theorem that the statement given was if both the pairs of opposite sides are equal. So they have given that the two pairs of opposite sides are equal. So you have got that the figure is a parallelogram. Now you are to take this condition. Sometimes in the proof part you will need to prove that the figure should be a parallelogram. So here you have proved by making both the pairs of opposite sides parallel. But sometimes you may need to show that both the pairs of opposite sides must be equal. So if both the pairs of opposite sides are equal, then this quadrilateral also will be called a parallelogram. So that means now you have learned one more that when both the pairs of opposite sides are equal, then the quadrilateral also will be called a parallelogram. Or else, if both the pairs of opposite sides are parallel, then also quadrilateral will be called a parallelogram. Now, one more is there that if at least one pair of opposite sides equal and parallel, that means you take at least one pair of opposite sides. Let us take this pair AD and DC. So if at least one pair of opposite sides of the quadrilateral equal and parallel, which means AB equals to DC and AB is also parallel to DC, in that case also the quadrilateral will be called a parallelogram. So that is the third condition. And the last one is if both the diagonals bisect. That means supposing you took this one, say you have joined these two, and then you have proved that here that AO equals to CO, and then you have proved that BO equals to DO. That means the two diagonals bisect each other at this point O. That means the diagonal BD bisect AC and O, or the diagonal AC bisect BD and O. So they bisect each other. That means O is the midpoint of BD as well as of AC. In that case also the quadrilateral will be called as a parallelogram. So now here comes the fourth condition. The first condition is if both the pairs of opposite sides are parallel, that means AB is parallel to DC, BC is parallel to AD. In that case, quadrilateral will be called a parallelogram. Other three ways, second way, if both the pairs of opposite sides are equal, that means if AB equals to DC and BC equals to AD. So that means the two pairs of opposite sides equal. In that case also ABCD will be called a parallelogram. Third one, if the diagonals bisect each other, that means if O is the midpoint of BD as well as of OC, which means AO equals to CO, BO equals to DO, then this figure will be called a parallelogram. Last one, if at least one pair of opposite sides are equal and parallel, then this will be also called a parallelogram. Let us take one more theorem. If the diagonals of a quadrilateral bisect each other, prove that it is a parallelogram. So prove that it is a parallelogram. So in short, parallelogram. So this is the third one. If the diagonals of a quadrilateral bisect each other. Now if the two diagonals bisect, then they will be also called a parallelogram. Now you are to prove it. So here they have given that if the diagonals of a quadrilateral bisect each other. So here you draw the figure as like a parallelogram. So it is say A, B, C, D. So now the diagonals. So you join the diagonals AC and BD because they have mentioned that the diagonals bisect each other. So now they have used the word bisect. So that means O is the midpoint of AC as well as of BD, which means AO equals to CO and BO equals to DO. Now you will make this figure. Now till now this is a quadrilateral. ABCD is a means quadrilateral. Now you will make that this quadrilateral should be a parallelogram. So it is given that the two diagonals will bisect. That means AO equals to CO and BO equals to DO. So you will make the figure a parallelogram by taking one pair of triangle, making them congruous. Either you make the triangle AOB congruous to triangle COD, or you make the triangle BOC congruous to triangle DOA. Either you take one pair of opposite, it means one pair of triangles. Let us take these two triangles. Now here they have given the diagonals of a quadrilateral. So here now this figure is a quadrilateral. So let ABCD be a quadrilateral. In which the diagonals AC and BD So AC and BD intersect at O, such that they bisect each other, that means AC bisect BD and BD will bisect AC. That means O is the midpoint of AC as well as of BD. So here such that AO equals to CO and then BO equals to DO. So this one is given because bisect, the diagonals bisect. Now to prove that quadrilateral, showing short quadrilateral ABCD is a parallelogram. Now comes the proof. So you may take either this opposite pair of triangle or you may take these two triangles. Let us take these two triangles. So in triangle, so AOB and triangle. So if AO, so you will get COD because AO corresponds to CO. So AO corresponds to CO. So you will get COD. So you took these two triangles. Now here you have got in these two triangles that AO equals to CO. So AO equals to CO. So AO equals to CO. Why? Because it is the given part. This is the given part. Till here, that is the given part. So this one is given. The diagonals bisect. So this one is given. Then you have got BO. So BO equals to DO. So BO equals to DO. This is also given. So these two are the given. So you took. Now you have got two conditions. Now you need one more. So here they have not said that this is a parallelogram. So you can't take AB equals to DC because this is only a means quadrilateral. So you cannot take AB equals to DC. That will be wrong. So here these two diagonals AC and BD meet at O. You have got a pair of alternate angles. Sorry, vertically opposite angles. But you cannot take also these angles equal. They are not alternate because it is only a quadrilateral where the opposite pair of sides are not parallel. So in a quadrilateral, opposite pair of sides they have not given as parallel sides. So you cannot take their alternate angles. Now only option is you will take these two angles equal. So they are vertically opposite angles. So here angle AOB equals to angle COD because it is a vertically opposite angles. So you took the three conditions. So therefore triangle AOB congruent to triangle. So triangle. So now here, so triangle COD by. So in this triangle AOB, so you took AO, the side, you took BO, the side, and you took angle AOB. So the triangles are congruent by side, angle, side. So by SAS, the two triangles are congruent. Now, as the two triangles are congruent, therefore their corresponding parts, that is angle A corresponds with angle C and angle B corresponds with angle D. So you may tell that angle OAB, so angle OAB is equal to angle OCD. So angle OCD. So here OAB, so this angle equals to OCD, so OCD. So these two angles are equal. They form a pair of alternate interior angles. So N angle. So angle B corresponds with angle D. That means angle OBA. So OBA equals to ODC. So angle ODC. So these are all simplicity. You have got it from the congruency of the two triangles. So now here OBA, so OBA, so this angle equals to this angle. So now there will be the same thing. So as these two angles are equal, or this pair of opposite angles are equal, in that case each of them will form a pair of alternate angles. So these two form a pair of alternate angles, and these two angles form the second pair of alternate angles. So therefore AB is parallel to DC. So AB is parallel to DC. Also, and AB equals to DC, because these two triangles are congruent. So you got AB equals to DC. This is also by CPCD. Now you see, this is the most important point. The same pair of opposite sides, the same pair of opposite AB and DC. So AB and DC, AB and DC. One you took parallel, and the same pair you took equal. So one pair of opposite sides, the single pair of opposite sides equal as well as parallel. In that case also, this figure will be called as a parallelogram. So since one pair of opposite sides are equal and parallel, therefore ABCD is a parallelogram. So today's class you have learned that the definition of the parallelogram, where if both the pairs of opposite sides are parallel, so AB is parallel to BC, if BC is parallel to AD, that is the two pairs of opposite sides are parallel, then that quadrilateral also is called a parallelogram. Then you have learned the remaining three. One is that if the diagonals bisect each other, that means here AO equals to CO and BO equals to DO. This is called the diagonals bisect each other. I have used the word bisect. So that means here O is the midpoint of AC as well as BD. In that case also the quadrilateral is a means parallelogram. Third one is if both the pairs of opposite sides are equal, that means AB equals to DC and BC equals to AD. If both the pairs of opposite sides are parallel, that means AB equals to DC and BC equals to AD. In that case also the figure will be called a parallelogram. Last one, if at least one pair of opposite sides equal as well as parallel as this one, just now you have proved it. AB is parallel to DC, AD is parallel to DC, and AB equals to DC. So AB and DC are also equal. So that means one pair of opposite sides equal as well as parallel. In that case also quadrilateral will be called a parallelogram. So there are lots of theorems. So these are the important ones. So I have done. But the next class I am going to start the chapter. So for today I have come to the end of this class.